a lot of people will come to me and they'll be like, hey, can we like do composting and get biogas at the same time? And the answer there is no, you can't do it, because what we're doing when we compost is we are creating an aerobic condition, and we're basically like farming all these aerobic microbes, and they're breaking down the material. And if you're trying to get biogas, you're doing the opposite. You're creating anaerobic conditions, and then you're trying to get the methane or natural gas that comes off the process. So you can't do both at the same time. You can do one and then the other, but you can't do both simultaneously. So to keep the aerobic conditions in this kind of environment with food waste, where there's a lot more energy, there's a lot more potential for emissions, we typically recommend some sort of aeration. You can do it with windrows, and we're going to talk a little bit more about that later, but for most people, aeration is recommended. This is some data that was collected by Compost Systems, and it looks at a food waste that's being composted with forced aeration and non-forced aeration, and then turning as well with a windrow turner. And as you can see at the start, the odor emissions are, about the same for both, which makes sense. It's the same feedstock coming in. And in the beginning, they kind of follow the same curve. And then there's a turn, and there's this huge spike in emissions for the non-aerated windrow. And that's because the conditions inside of the windrow have gone anaerobic, and you've just opened that windrow up, and all this stink has just been released to the atmosphere. Whereas with the aerated system, the odor emissions are much more controlled even after you turn. There's just a little spike, and then it kind of remains the same. So by adding aeration, not only are you speeding up this process because you're creating an aerobic environment that's more friendly to the microbes we want, but you're also controlling your odors significantly. This is some similar data. This is not looking at like a turned aerated process. This is just a static ASP process. And this is data from San Joaquin that was gathered in 2013. And this is actually for green waste, so it looks a little bit different from food waste, but it does a good job of illustrating how the emissions are different for the two different processes. This blue line is just a windrow, and we're mapping the CO2 equivalent emissions over time. And as you can see, in the beginning, the CO2 emissions actually kind of spike for the ASP, but then after that initial spike, they fall off and they really stabilize over time. Whereas with windrow, it's kind of a little bit more wishy-washy in the beginning, and then it stays pretty high for a prolonged period of time. So you're getting a lot more CO2 equivalents in the form of nitrous oxide and methane and CO2 emissions as well than with a windrow than you do with ASP. And again, this is for green waste. With food waste, this would be even more dramatic. So with all these things that I've just shared, I wanted to ask which of these two is better. And since you're all muted, I'm going to ask it rhetorically. So what we have on the left is a huge windrow. You have one of these scarab turners, probably 20 feet wide and 10 feet tall, or a small kind of windrow, which is maybe 6 feet tall and like 12 feet wide. And in both cases for this experiment, we're assuming passive aeration. So if you're doing food waste composting, which of these two would be a better solution? A lot of people are kind of drawn to the bigger windrow because it feels like A, you can turn a lot faster, and B, it feels like it's bigger, it's going to get hotter, it's going to compost faster. And while the turning speed is totally true, you're going to turn this material a lot faster, it's actually going to have a lot less air in it because it's so much bigger, it's going to settle a lot more, and the chimney effect that you are using to aerate a windrow is going to be reduced significantly. So what happens when you look at these big windrows is you'll see that like the very outside, maybe foot or two, is aerobic. It'll have an oxygen content of maybe 7–8%. But as you push deeper into it, the oxygen content drops dramatically. And you have this kind of, and sometimes the temperature will also drop dramatically. And that's because the inside of it has gone aerobic. So then when you turn this, you get this massive spike in odors because you just turn this aerobic. There's lots of acids and things like this that smell horrible. that get exposed, release a bunch of emissions as well. So if you are going to be doing food waste composting without forced aeration, we highly recommend using small windrows. I would say this windrow has a cross section of about 40 feet square. I might even go smaller than that if you're going to do food waste composting. You also, if you're doing windrow composting for food waste, you're going to need more bulking agent than you would with a forced aeration system. So that means you need to add more like wood chips, things like this into the mix to make sure you're getting that air in there naturally. Because the moment it starts getting dense, the chimney effect stops working.